Resultant AJ YouTube channel. I'm Vikas Sir. I welcome you all to this very important session on the subject of power plant and refrigeration air conditioning, which is of course important subject if you are preparing for RRB JE CBT2 and also preparing for SSC JE CBT2. My dear students, as you know, SSC JE CBT1 result has been declared, and many of you who have cleared SSC JE CBT1, first of all, congratulations to all the students from entire Resultant family. So my dear students, today we are going to practice questions on power plant and refrigeration air conditioning subject. If we talk about with respect to RRB JE, this subject is important, and also if you are preparing for SSC JE CBT2, then also it's very important. So please everyone quickly join me for this session. It's 8 p.m. and this is the timing for my YouTube class. Mechanical classes take place at 8 p.m. from Monday to Sunday, that means every day. So you can just note down this time and you can daily follow our classes. Okay. The technical classes for mechanical will take place at 8 p.m. Okay. So please forward this session to all the students, all the friends of yours who are preparing for RRB JE and also SSC JE. If anyone is preparing for SSC JE CBT2 now, because as you know, CBT1 result has been announced. So not just CBT1. Yeah, just a second. Yes, firstly, please let me know if my audio and video is fine, if it is coming clear to you. Is my audio video fine? Please tell me, everyone. So if you are preparing for SSC JE 2024 CBT2 and also RRB JE 2024 CBT2, then you can definitely join this session. RRB JE का एग्जाम कब तक होगा? Kaji Nemu, the exam of RRB JE may be conducted in the month of October, maybe in the month of October end. We are talking about the first CBT, okay, CBT1, okay, and the second CBT will definitely take place after 1.5 months, okay, at least in the month of December maybe. So this is a possibility. Those students who have just joined me for this session, please do not forget to subscribe our YouTube channel, and also if you have not liked and shared the session, then please do that and press the bell icon. My dear students, those who are joining me for the first time, my name is Vikas Sir and I'm faculty of mechanical having more than 7+ year teaching experience. I have taught these subjects so far: fluid mechanics and thermodynamics, applied thermodynamics. This is my qualification. This is my highest qualification, that is I have done my MTech in thermal engineering from Dhaka University through GATE examination, by qualifying the GATE examination multiple times. I have mentored more than 1 lakh students for these couple of examinations whose names are written, but some of the examination I have not written the names, like some PSUs, BARC, ISRO, DRDO, NHPC, THDC, so many examinations the students have cleared the exam, and even this time also SSC JE CBT1, many of my students whom I have taught have cleared the SSC JE CBT1 exam. So you can also follow my classes and you can follow all the mechanical classes at 8 p.m. So my dear students, one thing I want to tell you that at Resultant we have 3 type of courses for RRB JE 2024. One is only dedicated for CBT1 called as focus batch. This is the prices. This is the pricing for this CBT1 batch for RRB JE. For CBT2, that only for that is having technical and non-technical CBT2. We have AIM batch, which is having this cost. Offer prices right now this, and we have a combined batch called for CBT1 and CBT2 called as Mission batch, whose price is, you can see this is the MRP price, this is the offer price right now. If you want to study from Resultant, you can also download our Resultant app, that is must, if you want to attend our paid classes. Also, if you are having any query regarding our courses, you can just call on this number or you can just mail us here. Okay, आप यहाँ मुझे मेल कर सकते हैं हम लोगों को, ठीक है. For the mechanical, we are having 4 faculties dedicated for covering the technical part. Of course, you have known me by the introduction so far, but apart from me, we have Dheeraj Sardana sir, who will be teaching subjects in mechanical, Chandrasekhar sir and Suraj Gopi sir. So total 4 faculties will be taking the entire mechanical, okay, for you guys. for all the courses that we have, whether it is for RRB JE or future we may launch some courses for other JE exams. Coming to the first question, since you know that today we are going to cover the questions on the two subjects, power plant and refrigeration air conditioning. So let's quickly cover the first question. If the useful work done in a Rankine cycle is 840 kJ per kg, then what is the specific steam consumption? First of all, you need to understand that whenever these type of questions comes in the exam, you should know the formula. If you know the formula, then only you would be able to solve the question. The specific steam consumption, also known as steam rate, can be found by using the formula 3600 by net work. So in this question, the useful work or net work is already given, right? So if this is given, you just put the value here, you will get the answer 3600 by 840. The unit of specific steam consumption is kg per kilowatt hour. Okay, solve it and tell me the answer. What is the answer? Tell me, everyone. Yes. So it's all about the formula. For numerical part, you should remember the formula. If you don't, then no matter how good you are, you would not be able to solve the numericals. Okay. So for numerical part, you should know the formula. 4.2857, approximately 4.286. So that will be the answer for this first question. So far I have taken just one question, but those who are joining me for this session, hello Anand, good evening, welcome to the session. Yeah, Prisma, Subhadeep. So I think we have 3 to 4 students now. So we can, but that's a very less number, guys, come on. Even you are preparing for, if you think that SSC JE CBT2 will be, I think you, if you think that RRB JE CBT2 is still going to happen after a long time, firstly there will be CBT1, then CBT2, then my dear students, there will be CBT2 of SSC JE also, right? And SSC JE CBT2 will be conducted in just 1.5 months. Okay, anyhow by October. So in the month of October, if SSC JE CBT2 will become conducted, then you should be ready for it. Okay. Next, which of the following is false for air refrigeration system? You have to tell the false statement regarding air refrigeration system, not true statement. It is cheaper as air is easily available as compared to other refrigerant. This air refrigeration system is cheaper, having less cost as compared to other. So this is which of the following is false? You have to write the false one. There is no risk of fire as compared to the other refrigeration system. The weight of air refrigeration system per ton of refrigeration is high. It is saying high. The weight is high. So this is a false statement, my dear, because the reason why it is a false statement is the main advantage, of whatever is the advantage of air refrigeration, it is written wrong here. Advantage of air refrigeration is air refrigeration which is employed in aircraft. Okay, air refrigeration system. The main advantage which is also used in aircraft and also gas liquefaction. This is the main application that we use where we use this air refrigeration system. And the main advantage is low weight. The main advantage is low weight per ton of refrigeration. If you have seen any theory session that I have taken, okay, per ton of refrigeration, this is the advantage, and that is being written as a disadvantage here, which is of course not correct, right? Next, determine the power developed in a reaction turbine if the mass flow is 10 kg per second, blade speed is 20, and change in the velocity of the whirl is 150 meter per second. The power developed in a reaction turbine where the data is given for the mass flow rate. The mass flow rate is given as 10 kg per second. Again, same thing. If you know the formula, blade speed is 20 meter per second and change in the whirl velocity change is equal to 150. But all this data will not be any helpful for you. It will not be helpful if you don't know the formula, how to calculate the power developed. So how can you find the power developed? The power output of a reaction turbine is equal to mass flow rate into change in the bulk velocity into the blade velocity. Simple. You just have to multiply all the three things and you will get the answer. So it will be 10 into 150 into 20. So you will get 30 kilowatt. Clear? Yes, everyone. So what I want to tell you here is, if you find any new formula that you get while solving these questions, while practicing these questions, then if you have made any short notes for this subject, power plant, RAC, or any subject, then you can just update this formula in your short notes. Because when you are practicing some questions, let's say you know the formula, or if you don't know the formula, then while taking the live class, you will say, okay, I understood this, but your brain does not function like that. Your brain will forget this formula after, let's say, 1 month. Then what you will do? If suppose that same question will come in the exam, but you will forget the formula because you have not revised the formula, right? So that is why you need to note down this formula in some short notebook which you have made, which of course you must have made for each subject. If not, then please do make it. A nozzle expands air from 8 bar and 540 Kelvin to 5.8 bar and 495 Kelvin. Find the velocity of the air at the exit if the specific heat at constant pressure is 1.005 kilojoule per kg Kelvin. See, velocity at the exit of the nozzle, but this nozzle is containing air, and how you will find the nozzle velocity at the exit? So velocity at the exit, the nozzle, you know the formula, this is the formula. It is square root of 2000 into change in the enthalpy. Now, in this question, they have not given the enthalpy change. So how are you going to solve this question? Because in this question, they have given air. And if we assume that this air is an ideal gas, then we can write that for ideal gas, delta H will be equal to Cp into delta T, right? Enthalpy change is equal to Cp into delta T, right? So we can just put this value here. This will be root of 2000 into Cp into delta T. Clear? Just put this value and you will get the answer. 2000 Cp is equal to how much? 1.005. Delta T will be temperature difference. Temperature difference from 540 and 490. So this will be it will be H1 minus H2, right? It is 540 minus 495. Okay. So if you just put the value, you will get the answer. How much value you are getting by solving this question? Tell me. So approximately you will get 300 meter per second. 300 meter per second. Okay. If you use calculator, you will get the exact answer. Because if you solve this, you will get this value as 45. This will be 45. If this is 45, this is 2. 45 into 2 is 90. So anywhere it will be somewhere around square root of 90, 9. 9 is square root is only 3. So this will be 300. Williams line for the steam engine. You must be thinking, sir, why are you talking about Williams line? This we study for IC engine. But here we are talking about the steam engine, which is when we study power plant subject, this steam engine is important. So we have a Williams line curve. This Williams line curve is a curve between indicated power and mass of the steam consumption. So this kind of curve is made between these two. Okay, this is A and this is, and the formula we get is mass of the steam consumption is equal to A plus B into indicated power. This is a line. This line represents this equation. Okay. So what is the relation? This curve is plotted between steam consumption and indicated power. These are the two. On y-axis you have mass of the steam consumption. On the x-axis we have indicated power. So they are just asking ki Williams line curve is plotted between which two variables? Okay, indicated power and mass of the steam consumption. For the psychometric process, in case A, air is adiabatically saturated, and the case B, there is isobarically saturation of air done. Then saturation temperature in the case of A and B are. So psychometry you have studied in refrigeration, air conditioning. So we are following two type of cases. In the case A, we are trying to saturate our air adiabatically. So you know that when we talk about psychometry concept, with respect to concept of psychometry, two things are important. That is, when we say adiabatic, then we know what is the meaning of adiabatic. But with respect to psychometry, we are talking about constant enthalpy, a process where the enthalpy is constant, right? And because in the respect to psychometry, if enthalpy is constant, then wet bulb temperature is also constant. Okay. If you talk about isobaric in with context to psychometry, we are talking about pressure, obviously pressure, but which pressure? Vapor pressure is constant, and vapor pressure represents dew point temperature. Dew point temperature is constant. Dew point temperature means specific humidity is constant. So this is some basic concept that you need to remember. Hello Pushpendra, good evening, welcome to our session. Okay. So when we say isobaric with context to psychometry, we are actually talking about constant pressure, but the constant pressure itself mean here that dew point temperature will be constant and specific humidity will be constant, because here specific humidity is 0.622 of PV over P minus PV. So specific humidity is a function of partial pressure of water vapor, right? If pressure is constant, then the specific humidity will be constant. And since specific humidity and dew point temperature lines coincide, so that will be constant. Now let us understand how you are doing saturation. This is called as saturation curve. This is called as saturation curve. Why it is called saturation curve? Because on this curve, your relative humidity becomes 100%. We have 100% relative humidity. Air is fully saturated. So in case A, we are trying to reach our saturation curve across constant enthalpy or constant wet bulb temperature. And in case B, air is isobarically saturated. How you do isobaric saturation? Like this. Case number B. So when we do isobaric saturation, so that means pressure is constant, that means specific humidity is constant, and that means dew point temperature is constant. So in case A, you will get wet bulb temperature, and in case B, you will get dew point temperature. Clear? So the option C will be the right answer. Understood, everyone? Don't just remember this thing. Don't just mug up this thing, because it's important. The concept is important. Next question. Consider the following statement regarding steam turbine. The main objective of reheating in the steam turbine is to improve the dryness fraction. Why we do reheating in the steam turbine? The main objective is to improve dryness fraction. Correct. The reason why reheating was preferred or used in the first place for the steam turbine is to improve the dryness fraction, is to remove the wetness at the exit of turbine. Because if we don't do that, then the moisture at the exit of turbine will cause the deterioration of the blades. Okay, it will cause erosion of the blades of the turbine, material of the blades of turbine. So that is why we need to improve the dryness fraction. Okay, so this is correct. Reheating decreases the specific steam consumption. How it decreases the specific steam consumption? See, what are the effects of reheating? So when we do the reheating in the steam turbine, the main purpose of the reheating is, this: improve dryness fraction. This is the main purpose. Okay, so this is the main reason why this reheating was adopted in the first place. But with effect of reheating, the net work will improve, and if the net work will improve, then steam rate is equal to steam rate is also called specific steam consumption. It is 3600 by the network. If this is going to improve, this is going to decrease, right? So the correct answer for this question, hello, good evening. Well, Kuldeep, dear Kuldeep, welcome to our session. So both the statements are correct. 1 and 2 both are correct. Next is, consider the following statement about the compounding of the steam turbine. Now, compounding is a term which when we study about steam turbine, it is particularly the case where we try to remove some problems of simple impulse turbine. The simple impulse turbine has got some issues. That issues have to be resolved, and because of that we do compounding in impulse turbine, not in reaction turbine. It is done in reaction turbine, is totally false thing, it is incorrect. And Joule turbine is a pressure compounded turbine. So this statement is correct. Yes, Rative and Joule are pressure compounded turbine. This is correct, but this is incorrect. Here they are asking which is incorrect. So option A, 1 only is incorrect, because compounding is not done for reaction turbine. Compounding is used only for impulse turbine. Compounding, impulse turbine is suffering from some problem, and to solve that problem we use compounding in impulse turbine. Loss of kinetic energy is one problem. Loss of kinetic energy at exit and high rotor speed. To resolve these problems we use compounding. To solve this problem, these are the two problems in the impulse turbine. To solve this problem, solution is compounding. Solution is compounding. So reason we do compounding in impulse turbine is to solve these two problems. These problems are not in reaction turbine, so we don't require compounding for reaction turbine. RRB technician vacancy increased to 14,298. Okay, that's a good update. I think loco pilot vacancy has also increased. I have also seen lately that there has been some increment in the loco pilot ALP vacancy, and with that trend we can expect that maybe for RRB JE also there can be with coming time maybe some 100-200 vacancy might increase for RRB JE also. The volume flow rate at the outlet of an air compressor is that at the inlet is I think there should be some blank. There's a blank here. This is a fill in the blanks. Fill in blank. And that fill in the blank has to be filled from these options. Okay. The volume flow rate at the outlet of an air compressor is dash at that inlet, even though the mass flow rate of air through the compressor is constant. So there are two things. One is called volume flow rate and one is called mass flow rate. Right? Volume flow rate is also called discharge. Right? It is also called discharge. But here, when we say volume flow rate, discharge at the outlet of compressor, is it much less than that the inlet, even though mass flow rate is constant? That means what they are trying to say is, in the compressor, if they say that mass flow rate at inlet is equal to mass flow rate at the exit, that is, if in the compressor continuity equation is maintained, what do you understand by this? If in the compressor, क्या होगा सर, नॉन टेक तो अच्छा नहीं हो पा रहा है. So Gautam, you need to improve in the non-tech, right? So the problem to any solution to any problem is not cribbing about the problem, but working on the problem. If you just be worried about the problem that non-tech अच्छा नहीं है, तो non-tech सोचने से अच्छा नहीं हो जाएगा. अगर मैं मोटा हूँ, if I'm fat, if I'm bulky, if I'm overweight, then just by thinking that one day I will become lean, I will not become lean. I have to sweat it out. I have to do some exercise so that I can become lean. So the problem to solution to any problem is to work on that problem so that you can come out with some good result. Non-technical सभी का problem होता है. अभी मैं भी if I have to give RRB JE exam CBT, let's say suppose, and then I may not be able to clear CBT 1 because I have not studied non-tech from a very long time, maybe from last 10 years. So you have to study non-technical, right? Just study it. Clear? Chalo, what will be the answer for this question? Come on, tell me everyone. Many of you, usme to ITI wale, yeah, ITI is eligible. Maybe some of you have done ITI also, diploma also, BTech also. So you will be eligible for all the exams. You will be eligible for okay. So the right answer for this question is, just a second, it will be much less than. Why it will be much less than? Yes, tell me. So mass flow rate is equal to what? It is density into area into velocity. This is mass flow rate in the inlet. This is rho 1 A1 V1 is equal to rho 2 into A2 into V2. Now we know it very well that if mass flow rate is same and discharge, this is, we can write this is a discharge, rho 1 into Q1 is equal to rho 2 into Q2. We know it very well that in air compression, try to understand the concept. In air compression, air is compressed. And what is the meaning of compression, my friend? Compression means that pressure will increase. P2, pressure at the exit will be more than pressure at the inlet because it is a compression. And we know that density is a function of pressure. So density at the exit will be more than density at the inlet. So in this particular case, in order to maintain, if the mass flow rate have to be maintained constant, and if rho 2 is more than rho 1, then Q1 should be greater than Q2. Are you getting my point? If this quantity is more, then this quantity has to be less in order to maintain constant mass flow rate. Clear? So that is why discharge will be less than as compared to inlet. Volume flow rate will be less. Clear to everyone? Is it clear concept? समझ में आया? Very simple concept, because we have to maintain constant mass flow rate. And how it can be maintained constant? We have to decrease the discharge has to decrease accordingly because density is increasing already at the exit. The isentropic efficiency of a compressor is defined as a ratio of the isentropic compressor work to the. So there, with respect to, with context to compressor, there are two types of efficiency. One is called as isothermal efficiency and one is called as isentropic efficiency. There are two types of efficiency we study for compression. Isothermal efficiency is ratio of isothermal work, which is the minimum work input, divided by actual work input. But isentropic work is ratio of isentropic work to the actual work. Okay, so the right answer will be option C. Okay, next, in an ammonia water system, a rectification column is commonly used to. Rectification column or rectifier. Why we use a rectifier? Why use a rectification unit in the ammonia? Ammonia water absorption system, that is ammonia water vapor absorption refrigeration system. In this kind of system, why do we need a rectifier? Rectifier, you know why we require rectifier? Because in this system, ammonia acts as a refrigerant while your water acts as a absorbent. And because ammonia is a refrigerant, so this will be the main fluid which will be performing the cooling effect. But the problem is, when we try to heat the ammonia refrigerant, some of the water also becomes vapor, And if this water vapor will condense in the condenser and goes into the evaporator, it might freeze and block the evaporator, especially the expansion valve. So in order to prevent that, we need a rectifier that will minimize the concentration of the water. It is not minimize, it will eliminate. Actually, it should be elimination, but I don't know why they have written minimize, but there is the only suitable option here. The main purpose is to remove, to condense water and send it back to generator, and then finally to absorber and to absorber. So this is the main purpose. It basically removes the water completely. The refrigeration system of an ice plant is working between temperature of -5 and 25. This is a good question, and I'm very much having some expectation that this question might appear in your exam. Since few questions are like that, as a teacher I feel that this question is very important. So this is also an important question. There is an ice plant where the ice plant is working between these two temperatures, -5 and 25. Well, what do you understand by this thing? When we say this, it is working between these two temperatures, that means highest temperature to which heat is rejected is this, and the lowest temperature which is to be maintained by the ice plant is -5. This is the surrounding temperature, right? This is surrounding temperature, and this is the temperature of your system which has to be maintained. Clear? Now, please read the question carefully. Refrigeration system of an ice plant maintained between these temperatures produces 20 kg of ice per minute. How much? 20 kg of ice per minute from water at 20 degrees Celsius. A specific heat of water is given and the latent heat of ice is also given. What you have to find here is the refrigeration capacity of the refrigeration plant. So what do you mean by refrigeration capacity? Refrigeration capacity is also called cooling capacity. Cooling capacity or refrigeration capacity. How you will find this cooling capacity? What is actually happening here? Actually, what is being happening is the water which is at 20 degrees Celsius, water is at 20 degrees Celsius. We are firstly reducing the temperature of the water to 0 degrees Celsius. Then from 0 to 0 degrees Celsius, we are trying to make ice. Okay. And then from the ice 0 degrees Celsius, we are converting to -5 degrees Celsius ice. This is ice maintained at -5 degrees Celsius. This is what must be happening, right? I hope it is clear to all of you. So the water is firstly reduced in temperature. Sensible heat is removed from the water. Cooling capacity, when we say total cooling capacity. So suppose you are having a refrigerator. आपके पास एक रेफ्रिजरेटर है आपके घर पे, right? And you want to freeze water and convert into ice or ice cube, right? We all use ice cubes in our home, right? So we have just kept the water in our freezer. Water was at 20 degrees Celsius. So actually your refrigerator will be, if you calculate the total cooling capacity of the refrigerator, your refrigerator will be firstly cooling the water to 0 and then from 0 to 0 making ice, and then that ice will be converted to -5 degrees Celsius ice. Clear? So this will be, the total heat removed will be mass of the water into specific heat of the water into, what is the temperature difference? Temperature difference is 20 minus 0. This is the temperature difference which is because it is sensible heat which is removed from the water. And next thing is latent heat transformation. Latent heat transformation of ice will be done. That will be mass of the ice, because water will be converted into ice. So whatever will be the mass of the water, same will be the mass of the ice. That is 20 kg of ice is formed. So 20 kg water will be there into latent heat. Now you must be thinking, sir, after that you should also write this thing plus mass of the ice into 5. Yeah, we should write that. We should write that, but we can do that if you want to do it. So just put the values here. This will be, if I take mass of this outside 20, because 20 will be common, this is common here, right? Water is converted into ice, so mass will be outside. Specific heat is 4.2 for the water. But only problem, my friend, is why I can't use this formula? Because in order to use the third formula, I should need the data about specific heat of the ice. There should be the data about specific heat of the ice, but that is not provided to us. So I can't use this formula. I can't use this one because I don't have the information about specific heat of ice. So this will be just 4.2 into 20 plus 335, and this mass is outside. Okay, just multiply with this. Solve it, you will get the answer. How much answer you are getting? Tell me. I will not be using this formula. This will not be removed because specific heat of ice is not known to us. If we would have got this information about specific heat of ice, then we would have added this also. But itna effect padega nahi. So what will be the answer? Tell me. Yeah, try to solve this, everyone. So if you are scared about the level of the question, then I'm telling you we are not here solving. We are solving some CBT 2 level question. Okay, whether you are preparing for SSC or RB. So that's why the question level is like that. Okay, but I don't think it's too much of calculation. There may be some high level concept, but not too much of calculation. Next. Consider the following statement. The volumetric efficiency of a reciprocating compressor depends on. The volumetric efficiency of a reciprocating compressor depends on clearance factor, pressure ratio, index of expansion, index of compression. Of these statements, there are statements given above. Which of the following is correct? 1 and 2 are correct. See, volumetric efficiency of a reciprocating compressor depends on these terms. This is a formula for volumetric efficiency of a reciprocating compressor. Now, in this, all the terms mentioned, C is the clearance factor, or you can call it as clearance ratio. C. Pressure ratio is this. Index of expansion. Now, this is this N. N is not index of expansion; it is index of compression because it is a compressor. So, if it is a compressor, this will definitely represent index of compression, not expansion. The answer will be 1, 2 and 4. 1, 2 and 4 will be correct. Clear? Is it clear to everyone? Next, the degree of reaction for a turbo machinery in which heat drop in the moving blade is 8 and fixed blade is 12. Well, turbo machinery, there are different devices which are called turbo machinery, whether it is pump or it is called turbine or it is called compressors. They all come under turbo machinery. Okay, so in this turbo machinery, in all the application, we have to find the degree of reaction. Okay, and this is a common formula for finding the degree of reaction. In the numerator of this degree of reaction formula, we have to keep the heat drop or enthalpy drop of the moving blade. So just whatever data of moving blade is given, put it here in the numerator. And in the denominator, just add the total. Okay, both the data about moving and fixed blade, just add it, sum it here and just put it here. So moving blade enthalpy is 8. If you just do the sum of moving blade and fixed blade, it will be 20. So it will be 8 by 20. That will be 4 by 10. That will be 0.4. And 0.4 means 40%. Okay. Clear to everyone? Next question. A thermoelectric refrigeration system. Thermoelectric refrigeration system is basically a small refrigeration system which may be used for some cooling of electronic components. Cooling of electronic, just a second. Electronic components. Camping, in some camping application we use this, but this require low voltage not high voltage. It requires low voltage but DC power, DC input. Okay, high voltage is definitely that the voltage that you get in your home. But if you have to do some cooling inside your home, then why do you need a thermoelectric system? Thermoelectric system is used where we have gone for some camping, right, or some other expedition. So there you need low voltage. Okay, so it will take just low voltage and DC power, not AC power, the power that is stored in the battery. Okay, solar energy can be directly used in air refrigeration system, jet refrigeration, vapor compression or vapor absorption. See, solar energy is basically heat, because most of the solar energy contains heat energy. And if you are using heat energy, then which of the following is the application of refrigeration system which uses heat energy? So heat energy is used in the vapor absorption refrigeration system. It is also called heat operated refrigeration system. Okay. Yes, students, please be motivated, and those who are in the present in the session, please be present in the session for 10 to 15 minutes more, because session is of 1 hour. So I'll be finishing off the session by 9 p.m. Okay, the session will be completed by 9 p.m. I just need your 15 more minutes. So I request all of you to please continue with me for next 15 minutes. And anyways, I must tell you one thing, that those who have cleared CBT1, obviously you will be in a need of practicing some good questions. Those who have not cleared CBT1, of course there will be some other exams, right? You won't be sitting idle, right? You waiting for the other exam. You have to be prepared for that, right? Intercooling in a multi-stage. What is the purpose of intercooling? Is reducing the work input. So why we do intercooling in the multi-stage First of all, compression can be done in a single stage also. What is the main purpose of a compressor? Compressor is basically used to compress the air which is undergone suction. It will be compressed to very high pressure. Suppose we are compressing it from pressure 1 to pressure 2. That can be done by a single stage also. But when we do single stage compression, the problem which arises is majorly two problems. One is problem with the work input. Work input depends on pressure ratio, of course. So because in single stage compression, pressure drastically increases. It's a high pressure ratio, right? So because pressure ratio is very high, the work input will be very high. Work input is very high, that is the problem in single stage. So one of the reason why we do multi-stage compression, and in multi-stage when we do multi-stage compression, suppose the compression is done in multiple stages, then between each stages of compression we follow intercooling. That is cooling means heat rejection between the stages. So the intercooling is preferred between the stages. It is not preferred, it is used between the stages. Okay, between each stage of compression. And with the help of this, work input is reduced. Okay. Which is the following is the working fluid in an air cycle? And yes, you are saying yahi sara hai, but try to understand this RRB JE, no matter if for mechanical the vacancies are 4,035, and that is also combined vacancy sharing with electrical, but try to understand one thing, these vacancies of railway we have got after 5 years, and those who are still not 36, who have not crossed 36, even I have not crossed 36, you are still having the opportunity to be employed in India's largest central government company, okay, which is Indian Railways, and you get so much benefit. You can ask Vikas Sir, okay, you know Vikas Sir, he is just chilling out there. He is having 6 months of training. He is also studying during the training, but while training he is also living in the apartment given by Railways food is also provided by them, and having more than 50,000 per month salary during the training, only 53,000 something. Food and home is accommodation is provided by railway. Apart from that, he will be also traveling. So much of benefit. And when you become a JE, other benefits. When you get promoted to section engineer, more benefits. So just think about this, why you need to be selected as a JE in Indian Railways. Just work for it. ये मत सोचो कि पहला पेपर CBT 1 है, ये मत सोचो you are weak in CBT 1, you are weak in non-technical. If you think you are weak, then just leave this race of 25 lakh students who might fill the exam of railway. पहले से रेस से बाहर निकल जाओ, कोई फायदा नहीं है. If you are feared that CBT 1 will be tough, I will not be able to clear non-technical. If you think that it's tough, then just get out of the race. And if you think that you will be able to clear RRB JE exam, then just work for it. Okay? Which of the following is the working fluid in an air cycle refrigeration system? पहले अपने अंदर विश्वास जगाना पड़ता है. SSE Vikas Sir. No. He has cracked RRB JE. So he's a JE right now. Okay. The right answer will be, most of you must be thinking compressed air, no. Saturated, no. Air at high, no. It is gas. Gas is used as a working fluid in the air cycle refrigeration system. Okay. If compression is achieved by trapping a refrigerant vapor in an enclosed space and then reducing its volume, it is called as. So what we are trying to do here is, we are trying to do the compression, but for that, we are just making the refrigerant to enter into a closed space, and then slowly we are reducing its volume and then increasing the pressure. So this process of firstly allowing the air to enter or vapor to enter into a large volume and slowly reducing the volume and increasing the pressure, this is called as positive displacement type compression. This is the principle of positive displacement compression. Okay. And in this positive displacement, we have reciprocating compression. This comes under the positive displacement, and rotary compression. They come under the positive displacement compression. What is the disadvantage of ammonia using as a refrigerant? Ammonia is a refrigerant used for use in many applications, but what are the disadvantage? Ammonia is also having some disadvantage. First disadvantage is it is a toxic. Yes, it is a toxic in nature. So what are all the things mentioned here? Ammonia is toxic in nature. Yes, it is a toxic refrigerant. Okay, toxic means something which is not good for the environment. Okay. When two refrigeration cycles are used in series with two different refrigerants, the system is known as. We are using two systems. One is this is vapor compression system like this. Okay, this is one vapor compression system. Vapor compression system like this. And this is another vapor compression system like this. Okay, so these two vapor compression systems are connected in series connection. And how they are connected in series connection? The condenser of the lower system will reject its heat to the evaporator of the upper vapor compression system. Okay, so this will be having refrigerant 1, different refrigerant. This will be having different refrigerant, and this type of arrangement of vapor compression cycle is called as cascade refrigeration system. Okay, the temperature of the air recorded by a thermometer when the bulb is covered by a cotton wick. Wick means basically a kind of a cotton which absorbs the moisture. It will absorb the heat of the, or it will absorb the heat of the water. Okay, so in this way, this temperature is called wet bulb temperature. Okay, there is a thermometer which is also called sling psychometer, and the bulb of this thermometer is covered by a cloth, wet cloth. Okay, this is called as bulb of thermometer. Okay, it is covered with a wet cloth. It is covered with a wet cloth or it is covered with a cotton wick. Okay? So this is called wet bulb temperature. The process generally used in summer air conditioning to cool and dehumidify the air is, in summer air conditioning, which is of course summer, like right now we are using air conditioner. In air conditioner, the process which take place is called as cooling and dehumidification. Why we do cooling and dehumidification? Because cooling is reducing the dry bulb temperature, the temperature of the air, and dehumidification means reducing the specific humidity, which is the moisture. And in the summer, when we use our AC, air conditioner, what is the main objective? That AC should reduce the temperature and should reduce the moisture. Okay? Yeah, this thermometer is called as sling psychrometer. Sling psychrometer. Those who have studied with me, you know that I tell you everything. The COP of this system, let's say, is 1, COP of this system is 2. Okay, so cascade system COP or vapor compression in series COP can be calculated by using this. So if these two systems are connected in series, then this is how you can find the COP of combined system. Okay. Next question. Water at 42 degrees Celsius. 42 degrees Celsius is sprayed into a stream of air at atmospheric pressure having dry bulb temperature of 40. That means water is at 40 degrees, air is at 40 degrees Celsius. And on this air, we are trying to spray hot water because it is at 42. That obviously it will be at high temperature than the air. And we are trying to spray this water on the air. The wet bulb temperature of the air is 20. The air leaving the spray humidifier. Why it is called spray humidifier? Because not only it is spraying hot water, it is also trying to humidify the air. The air which is at 40 degrees Celsius also getting humidified. So obviously it is getting humidified. That means this will not be the answer. It is a humidifier. The air is getting humidified but not saturated. Okay. So but the water, just think about it. Water at 42 degrees Celsius, if sprayed on air, if it is sprayed or sprinkled on air, which is at 40, so obviously the air will get heated up, na? So air will get heated and humidified. Okay, air will get heated up because water is at 42, air is at having dry bulb temperature of 40. This is the air temperature, right? And wet bulb temperature is 20. Obviously air is not saturated because the dry bulb temperature is more than wet bulb temperature, so air is not saturated completely. But because water temperature is more than the air temperature on which water is sprayed, so it will get heated up, not cooled. Understood a concept or not? So it will get heated up. And because water is sprayed on the air will absorb some moisture. It will get humidified. Okay. And what this process? This is a process used in winter air conditioning. In winter air conditioning, we use this process of heating and humidification. Okay. The vapor compression refrigeration cycle is inherently irreversible cycle because why we say vapor compression cycle is irreversible or inherently irreversible cycle? Because we know it very well that if you see vapor compression cycle, what are the process in the vapor compression cycle? In the vapor compression cycle, firstly we compress the refrigerant vapor, then we reduce the temperature, bringing the superheated vapor to saturation temperature, then we reject the heat of the saturated vapor and condensing them to saturated liquid, then we slowly with the help of an expansion device we reduce the pressure and temperature, right? And then it is evaporator. Okay, so which of the following process is irreversible? This. In vapor compression cycle, we use a device called capillary tube, and capillary tube is a throttling device, and throttling, my friend, is a irreversible process. Okay, the compressor immediately irreversible because compressor is non-ideal, evaporator is non-frictionless, condensation process not isothermal, of the use of expansion valve instead of expansion engine. Yes. Why? Because we use an expansion valve, and that expansion valve is Because expansion in the expansion engine or cylinder, we have isentropic expansion. And isentropic expansion is reversible adiabatic expansion, that is not irreversible. But expansion valve that we use here is capillary tube, which is a throttling device. So, and throttling process is irreversible. Okay. For minimum work input in a two-stage compression process, the intermediate pressure is the, for minimum work input, if we say minimum work input in two-stage compression, let's say we are doing multi-stage compression. In multi-stage, we are just doing two-stage compression. Okay, this is first stage compression followed by an intercooling process. And this intercooling is obviously perfect intercooling, because only in the perfect intercooling we have minimum work input. Okay, this is second stage compression. So this is P1, this is P2, and this is P3. So if it is a perfect intercooling, for perfect intercooling in multi-stage compression, guys, don't go anywhere. It is, I will just take 2-3 more questions and then I will end the session. Perfect intercooling case, the work input is, firstly work input is minimum. That is, and when the work input is minimum, when it is isothermal compression. So that means it is an isothermal compression, that's why the work input is minimum. And in the isothermal compression, perfect intercooling, the pressure ratio in all the stages becomes equal. Because we are talking here two-stage compression, so the pressure ratio will be P2 by P1 is equal to P3 by P2, that will be equal. Also the work in the stages becomes equal. Work of the first stage will become equal to work of second stage. Okay, so these are few advantages of perfect intercooling. But here, if you see this particular case, that P2 by P1 is equal to P3 by P2, that means P2, which is also called intermediate pressure, will become the square root of P1, P3. What is the meaning of square root? Geometric mean. Geometric mean of what? Suction. Suction means P1 pressure. Discharge pressure means P3 pressure. This is square root of, or geometric mean of, suction and discharge pressure. A condenser of a refrigeration system rejects heat at a rate of 120 kilowatt, while compression of the system consumes power of 30 kilowatt. The COP of the system will be. See, if we are talking about a refrigeration system, in the refrigeration system, work input or power input is equal to heat rejected minus refrigeration effect. Okay. In this particular case, we are having the data about heat rejection. The power input is given, the heat rejected is given, but refrigeration effect is not given. So refrigeration effect will be equal to 120 minus 30, which is 90. And COP, my friend, is equal to refrigeration effect or refrigeration capacity divided by power input or work input, which will be equal to 90 by 30. That will be 3. Okay. In an aircraft refrigeration system, the pressure at the cooling turbine outlet is. Aircraft refrigeration system uses air refrigeration system. Bell-Coleman cycle, reverse Brayton cycle. Okay, also called as Bell-Coleman cycle. This is the last question of today's session. So guys, I have already requested all of you to be with me till the end of the session. Bell-Coleman cycle, reverse Brayton cycle. Okay, reverse Brayton cycle, Bell-Coleman cycle. And if you see the Bell-Coleman cycle, the cycle works in anti-clockwise direction. If I show you the temperature entropy diagram, firstly we do the compression, then we do the heat rejection, and then we do cool. This is a cooling turbine. Expansion take place. 1, 2, 3, 4. And this is called cooling turbine, because it is reducing the pressure temperature of the air. Okay. So the pressure at the exit of the turbine is called cabin. Why it is called cabin pressure? Because obviously the turbine will reduce the pressure and temperature of the air, and then that cooled air will be supplied for cooling purpose. Where? To the cabin, where people are sitting, right? Cabin is that place where the passenger used to sit, right? That is a place called cabin. Which of the following is not an essential component of any refrigeration system, where refrigeration effect produced by vaporization of refrigerant? Not an essential component of any refrigeration system where produced by compressor, condenser, evaporator and expansion device. What they are trying to say, which of the following is not an essential component of any refrigeration system where refrigeration effect produced by vaporization. Refrigeration effect produced by vaporization of refrigerant. So there obviously one thing is important. Evaporator is essential. ये essential तो हो जाता है, because obviously this will be needed. What will not be needed there? What will not be needed? Yeah, compressor. Compressor is something which is not needed, because if you see the case of vapor absorption refrigeration system, there we don't use compressor, but we have these three devices, but not compressor. Compressor is replaced with absorber pump generator. Okay, in vapor absorption system, compressor is replaced with, rather than instead of using compressor, we use absorber pump and generator. Okay, vapor generator. So this is not an essential component because it is not required everywhere. Okay, all the other questions will be taken in some other sessions. My dear students, I want to tell you about two important batches that we have for RRB JE. One is called CBT2 batch, which consists of technical portion. Technical portion will be covered in English, and these are the 4 faculty who will be taking this complete technical batch of RRB JE CBT2. The price of the batch is 3,999 currently. Okay, that is offer price. And we also have mission batch if anybody wants to prepare combined for CBT1 CBT2. So combined fees is 5,499, but this batch is called mission batch. Okay, that's all my dear students. If you have enjoyed today's session, then please do not forget to like and share the session. Now my next class will be on Monday. I will see you on Monday, but mechanical classes will be continued at 8 p.m. Tomorrow also there will be mechanical class, but my classes, if you want, my subject classes will be on Monday, okay, 8 p.m. But tomorrow there will be mechanical class, I think by Suraj Gopi Sir. Okay, tomorrow 8 p.m. Suraj Gopi Sir will take, I am not sure about 8 p.m. because I think he takes class at 9 p.m. I have to confirm that. But Suraj Sir will come tomorrow. Mechanical class will definitely take place, and he will be taking either 8 or 9 p.m. I am not sure about this. But my class will be on Monday, next class. Okay. Thank you so much. Have a nice day. If you enjoyed the session, then please do not forget to hit the like button and share the session also. Thank you everyone. Have a nice day. See you on Monday. Thank you everyone.